There are 6 different techniques. These are the actual 3D prints of work. After the molding and casting, sculpting, molding, and casting, you get a fake Kristen, and everyone thinks, no, that's her, no, it's a puppet. So we're able to bring this stuff to life from 3D printing. Did 3D printing produce the final? Absolutely not. 3D printing shaved the time to make it possible for us to get to the final. And I think that's the big point here. This is all about time and delivery for us. If you can have a tool that shaves that time to get you to your end result quicker, but also gains you a pocket of time to even be more creative, that's what it's about. So, fun stuff. We want to keep moving forward. Now the company loves it. This is how we're doing things. So to this date, we went from that one little machine. We've had a Connex 3 now that was just announced last week, the color machine. For 10 months now, we've been beta testing it. We have a Connex 500. We have the 8260V that has 15,000 hours of print time on it to this point. It's printed right now. We have Fortis 250 MC for FDM builds for strong parts. We have an Envision Tech Per Factory 3 for some micro face detail type things for collectibles. We even have a MakerBot replicator fluid that we use for early on iterations for fittings of chin cups, buckle straps, little custom straps. If you look at the exosuit we have there, all those buckles, that stuff's not store-bought. We model that stuff up and make buckles. So we utilize every technology to do things like that. So, where do we go from there? We were approached for this movie, not to do the full movie necessarily, but they wanted to get to the photo shoot of Tom for the movie poster ahead of time, the way the studio wanted it. And they were having a problem with the leather jacket with the digital designs inside of the patches. So they didn't have the approval yet what the final design was. So traditionally it wasn't going to work. So what we decided to do was scan one of our owners who has a similar build of Tom Cruise. We acquired all of his data in. Then from there, we sculpted these pieces that were going to be put inside of the leather jacket in ZBrush and pumped up the texture, leather texture, to see if it would be reproduced in the print. Now, since we were limited with time for this test, we decided to try to print this flexible on the machine. But the problem with a flexible part, especially in this of nature, is the minute you hand over a flexible part to someone, what do? They start bending it, and then eventually it tears right away. So we were still on the small Eden printer at this point, because the other printers, the multi-material printers, were already in use on large jobs. But I decided to take advantage of a little feature inside of the printer called gloss mode, which basically, when you print, you need support structure. But you can simulate a gloss finish on anything that doesn't need support, which will give it more of a rigid, add some rigidness into the flex, so it has a little bit of a memory, making it a little bit more tear resistant. It will still tear over time, but it will hold up longer. So I decided to print them face down and gloss the inside of it, so it would always be able to shred it back if someone was to pull it. And we took it from there, and that's the first flexible piece that came off. The back side is gloss, so if you would bend it in half, it would still come back. Did even more tests. Chest piece. Because you can see the 49 in there. At one point it changes to a 52. So to do this by hand with the deadline that we had, it would take forever. And then those are 3D printed inside of the leather jacket, which is pretty cool, just for proof of concept. So we're going to here, and there he is wearing them for some different test things. The cool thing about that, this whole project, was handing over a 3D printed part that like a 70-year-old Armenian seamstress sewed into a leather jacket. I think that's really, really cool. I mean, it doesn't get much better than that. Technology holds the way of doing things. Marriage, there you go. So, now we get to play with the comics after that one. So, really cool. We can even push it even more. Where do we go from there? We had a proof of concept project where they wanted a full-on gauntlet, high detail, flexible, and we do it all on a printer and marry it with traditional fabricators. So we came up with something that's inside of these printers called overmolding, where I can basically take a piece of geometry, have the core of it be printed in rigid, then wrap it with up to a 2mm coating of a flexible material. So can we keep the detail? This is printing at a 30 micron level now. We're not at 16 microns. We're generating an A and B material that needs to be knit simultaneously on the fly. So all of these pieces that you see here are flexible materials, but with a rigid core of 0 white plus inside for high impact strength. So detail is still there. We're able to do it. We're able to break all the fingers out into digits. Now the thing that you have to understand here is this is within days of moving forward. This is not weeks, this is not months, this is days. So all the detail is there. And then the next question is, can we paint this stuff? What can we do with it? Is it going to assemble? Can we boolean out rings and have that rigid core so we can sew and tie into it? So there's the final of it coming together. Pretty phenomenal piece. It looks like it's right out of some sewing. Oh, but everyone thinks it's smoke and mirrors. You can see all the rings that were modeled in, so we can tie them and fabricate them to leather. And then we utilize a lot of earth magnets at the shop. You can see right there, after the zipper comes up, we'll just slam on our covering pieces and roll it back. Printed with leather on the inside. It's a pretty neat piece. So, I'm going to finish off my presentation by showing what's been done recently on our Connex 3 machine. I don't know if there's anyone here know what a Connex 3 is yet. So Connex 3 is basically the Connex 500 by Stratasys, which was the first multi-material printer that could jet 2 materials at the same time, blending them together to come up with 14 different material properties of one piece of geometry at a 30 micron level. It's pretty high resolution for jetting 2 materials together. So, Connex 3 has all of that, but it adds in a third material so you can have color. That's right off of the printer. All of the detail is in there, jetting 3 materials at the same time, coming up with a color palette, deciding into shells, and pulling them out.